Now here we see the summary of four standard forms of the parabola. So as shown here, firstly we have the diagram of the four parabola. You can see that the first one is the parabola that opens towards the right hand side. So that is where we can see. Then the other one is opening towards the left, and the third one opens above or upwards, and the last one opens downwards. Okay, so these are the four important configurations or the orientations of the parabola. Then next we can see the equations of them. As you can see, the parabola which are opening rightward or leftward have the y square term and the other term is negative, whereas the remaining two have the x square term and the other term is once again negative. In case of vertex, since all of the parabola have the same vertex, it is the origin that is common to all. Then focus also, it's as shown here, that is depending on where the focus lies. Okay. The focus is shown here in green dot. Okay. And by convention we take a as a positive number. So when we say that for the first parabola the focus lies at a comma 0, that means here we are taking the value of a as a positive number. Okay, and based on that we can derive the coordinates of parabola for the other configurations also. Alright. Then we have the directrix. Once again we have seen in the derivation of the standard form that the directrix will lie on the opposite side, of the focus. So wherever focus lies, the directrix will be on the opposite side. So the equations of the directrices are given for all the four cases. And lastly we have the focal distance of any point on the parabola. So by focal distance we mean the distance of the point from the focus of that parabola. Right. So this also is given in this table. Moving on, we have a special term called as the latus rectum of the parabola. Right. It's a very specific segment in case of a parabola. So it's given what is the meaning of that. The segment passing through the focus of parabola being perpendicular to axis of the parabola and having its extremities lying on the parabola is called as the latus rectum. So by latus rectum what we mean is through the focus, if we draw a perpendicular segment and we name the points where it meets the parabola itself as say L and L dash. Okay, so that particular segment is called as the latus rectum. Now suppose we have to find out what are the coordinates of the extremities of the latus rectum, that is what are the coordinates of the points L and L dash. For that what do we do is we have since we have drawn a perpendicular to the axis through the focus, clearly their x coordinates will be nothing but a, because that's the x coordinate of the focus also. Okay. And now since we have considered the standard parabola here of the type y square is equal to 4ax, so therefore let us substitute the x coordinate as a. So therefore that gives us y square is equal to 4a square clearly. Therefore y is equal to plus or minus 2a. Hence the upper point must have the y coordinate as 2a and the lower point, the lower extremity must have the y coordinate as minus 2a. Okay, so those are the extremities of the latus rectum, and hence if you want to calculate the length of the latus rectum, clearly from the figure it is seen that the length must be 2a plus 2a, that is nothing but 4a. So that's the length of the latus rectum for the parabola y square equal to 4ax. So it's easy to remember that whatever is the coordinate of x, that value itself is the length of the latus rectum.